We're going to start putting some ideas together in this video. We've talked about the idea of precision and the sampling distribution, and we want to match those up. So once again, precision is measured by the standard error. It's reflected in the spread of our sampling distribution. It's measured by the standard error, which we define to be the standard deviation of the sampling distribution. This tells us how much our sample proportion typically varies from the population proportion. We know our samples won't always match the results of the population, so we need a number to see how far off we may be. We're going to calculate the standard error with this formula. And this is something you definitely need to know for this class. The standard error is the square root of P, which is the population proportion, 1 minus P, in parentheses, that same P is out front, all over N, where N is the sample size. Note that if P is unknown, which is going to happen more and more frequently as we progress, we can use P hat to find the estimated standard error. If the population proportion is unknown, we can use the sample proportion, P hat, in order to find the estimated standard error, how much our samples typically vary. Let's make this more concrete with an example. Suppose a college has a total of exactly 10,000 students and 25% of students live less than 5 miles from campus. So that's our population. Our population is 10,000 students and 25% of the students live less than 5 miles from campus. That tells me P is 0.25. It's this percentage as a decimal. It's referring to the entire population. Now, we couldn't possibly talk to all 10,000 students in a reasonable amount of time, so we're planning a survey of 100 people without replacement. We want to calculate the proportion of people in our sample who live less than 5 miles from campus. We want to know two things. What should we expect from our sample proportion? And what is the standard error? Then what do each of these mean? So I'm going to say I expect P hat to be 0.25. I'm going to expect that my question is clear and concise, that we take a random sample. So my sample proportion shouldn't be 80% live less than 5 miles from campus or 5%, but it should be fairly close to 25%. So if I had to pick one number to describe it, I would pick 0.25. For my standard error, I'm going to go to the formula from up above. It is the square root, so I hit second and x squared on my calculator. So square root of P was 0.25. Then it was parentheses in the formula, so I've got those on my calculator, parentheses, 1 minus that same 0.25 that's out front. And this was all over the sample size. In this case, we're going to survey 100 people, so all over 100. You don't have to go piece by piece. You can type this in all at once. I just hit enter, and my standard error will be 0.043 if I round that to 3 places. And typically, we want to round standard error to 3 places, just like we did our standard deviation back in some earlier chapters. So I expect P hat to be about 25%. I expect the standard error to be about 4.3%. Now, we've got these numbers calculated, but what do these mean? What does this tell me? I can say I expect P hat to be 0.25. But it can typically vary to be from 0.207 to 0.293. To get these decimals, I just took my expected p-hat, that 0.25, and I subtracted that 0.043. That's 0.207, or 20.7%. And then I took that 0.25 and I added that 0.043. It's sort of giving me a range of numbers. I would expect this sampling distribution to be normal. We'll get into that in a couple of videos, but just trust me, with 0.25 in the middle, that's the mean, the population proportion. If you go down a standard error, which is like your standard deviation, if you subtract one of those, that will be 0.207. If you add one of those, that would be the 0.293. And you can even throw the empirical rule in here, and this should be about 68%. Before we close this, just a quick note. Increasing or decreasing the size of the population has no effect on bias or precision. All of our ideas are based off of sampling alone. We're using samples to make assertions about the population. The population size has no effect really on what we're doing. However, increasing the sample size makes the distribution more bell-shaped and narrow. When we do that, there's less bias. Our p-hats are closer to our p's, and there's more precision. We're consistently close to p with our p-hats. Increasing the sample size will make the standard error smaller. That's a good thing. You're making your error smaller, so there is less error. That's why it's good. We'll continue on this idea more in the next few videos.